All right, so we've already talked about absolute value back last week when we were dealing with order of operations. So when we're talking about absolute value equations, though, there are generally two acceptable answers, because if you're talking about distance from zero, because that's what absolute value means, how many numbers are 7 away from zero? It's 2, right? If you got 0 here, 7 away from 0 happens on this side and that side. So what are the two possibilities here? 7 and -7? Yeah. So possible values here would be x equals 7 or -7. Because if you plug those numbers into the absolute value bars, the absolute value of 7 is 7, but the absolute value of -7 is also 7. So if you're thinking about the answers for, all right, if you got this number here, there should be two answers to that number there. However, on number 2, what would we say for that one? What's that? None. Why? You did say none, right? Yeah. Okay. So no solution. How come? I agree with that, by the way. That is the correct answer. Absolute value is distance from 0, right? Can distance be negative? No. Because it has to do with what's inside. So if you think about a number line, on a number line, there are two numbers that are 7 away from 0, right? If you go to 0 on your number line, you can count 7 this way to get to +7. And you can count 7 this way to get to -7, right? But we're still counting 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. We're counting up from 0. If -4 was in here, then yes. If -4 was in here, this answer would be 4. But absolute value, the answer to an absolute value equation cannot be negative, because there's no such thing as negative distance. So this is saying, what numbers are -4 away from 0? There are two numbers that are 4 away from 0, which would be -4 to 0, +4 to 0. Those would be 4 away from 0, not -4 away from 0. -4 away from 0 doesn't exist. It's not a thing. So if the answer is negative, it's no solution. Absolute value answers must be a positive number or 0, but they cannot be negative. So if this number over here, after the absolute value, is a negative number, it's got to be a solution. And I know that you saw that in Algebra 1 briefly. You probably didn't spend much time on absolute value equations in Algebra 1. So steps to solve: isolate the absolute value expression. You cannot distribute into, even though absolute value is a group, it is a group that you cannot distribute into. So don't ever distribute into absolute value. Isolate the absolute value expression by doing the opposite of whatever is next to it. Then you're going to create two cases. You're going to create two cases because as long as the answer to the absolute value is a positive number, that means the stuff inside the absolute value could be either the positive or negative version of this number here. Because that's how absolute value works. It could be on the positive side or the negative side of 0 in order to get to 0. Then you're going to solve both equations. And then it says to check for extraneous solutions. I don't know if you've ever learned what extraneous solutions are. Does that sound familiar to anybody? I wouldn't imagine. Okay. So an extraneous solution, oh, here's a good question. What are extraneous solutions? These are solutions. So solutions that do not work with the original equation. So it does happen on occasion where you can solve for two values of your variable, and then when you check the answers, one of them doesn't actually work with the original equation, which means there would only be one solution as opposed to two. I think in the past, whenever you solve for an absolute value equation, you just accepted both answers as correct answers, or you said no solution because the thing equaled a negative number. you didn't really have that in between of like, well, what if only one of them works? So let's go ahead and double check. So let's take a look at number 3. So this one, we don't have to isolate the absolute value because it's already by itself. And it says that all this stuff in here has an absolute value equal to 5, which means that everything inside this set of absolute value bars is either equal to +5 or -5 because there are 2 numbers that are 5 away from 0. So either the stuff in here equals 5 or the stuff in here equals -5. So there's 2 potential values for x that work with the original equation. The nice thing about solving both of these is that both equations use the exact same steps. They'll get different answers, but the steps are the same. We're going to add 9 to both sides of each of those to get both of our answers. So if we add 9 to 5, you're going to get 14. If you add 9 to -5, you're going to get 4. And so we're saying that those are both valid options for x back with our original absolute value. Let's just double check them real quick. What does 14 minus 9 equal? 5. All right, absolute value 5 is 5. That's fine. How about 4? What's 4 minus 9? -5. Is -5 5 away from 0? Yeah, all right. So these are both good. So both of those are correct answers. All right, next one. This one's already isolated as well. So that means that everything inside the absolute value here either has a value of 3 or -3. So I'm going to flip the whole thing around when I write these. I'm going to say 2k plus 7 equals 3. I'm also going to say 2k plus 7 equals -3. And then we'll just solve for both. And both of them have the exact same steps, which is really convenient. And if you want to show the work for solving here, you can, or if you just want to write the next step because you can use mental math to do it, I'm fine with that too. So 3 minus 7 is -4, so that'd be 2k equals -4. Divide by 2 and k equals -2. There's one of them. The other one, let's see, -3 minus 7 would be -10, so that'd be 2k equals -10. Divide by 2 and k equals -5. And if we plug them back in here, let's see, 2 times -2 is -4. -4 plus 7 is 3. The absolute value of 3 is 3. That checks out. 2 times -5 is -10. -10 plus 7 is -3, which has an absolute value of 3. So again, both of those answers work perfectly fine. So we will accept both of those as correct. All right, for number 5. We have to isolate the absolute value first. So basically get this group by itself. So we have to subtract 17 from both sides before we can write our 2 equations. So the absolute value bars have to be alone on one side of the equation before you can write your 2 equations to solve for what's inside. So subtract 17 from both sides here, which will be the absolute value of y minus 1 is equal to 6. Then you can write both equations. Y minus 1 equals 6. And y minus 1 equals -6. For each of these, you're going to add 1. So one of them will be y equals 7, and the other one will be y equals -5. And then we're going to go back to the original equation to make sure that they both work. So let's see. 7 minus 1 is 6. The absolute value of 6 is 6, and 6 plus 17 is 23. That's fine. -5 minus 1 is -6. The absolute value of -6 is 6, and 6 plus 17 is 23. So once again, both answers work perfectly fine. Bless you. All right, number 6. We need to isolate the absolute value. So what do we have to do first on this one? Divide, yeah, divide both sides by 3. So that would be the absolute value of m plus 8 equals 13. And we set those equal to +13 and -13 and solve for m. So m plus 8 equals 13. M plus 8 equals -13. Let's see, this would be 5. And over here, we'll have, what is that, -21. And then, figure out if these work or not. So 5 plus 8 is 13. Absolute value of 13 is 13. 13 times 3 is 39. Negative 21 plus 8 is negative 13. Absolute value of that is 13 times 3 is 39. So once again, they both work. Good to go. All right. Is this a good pace? Too quick? Or are we all right? Okay. Next one. What do we have to do? What's our first step? Divide by 16. Okay, what's negative 32 divided by 16? Negative 2. All right, so let's see. R, absolute value of R minus 5 equals negative 2, and we're done. The answer is no solution, right? Because you can't have it equal a negative number. So this number over here, once the absolute value is isolated, is negative. No solution. In fact, I think these are the easiest ones because you don't really have to do anything. Once you get the absolute value isolated, if it's equal to a negative, you're done. However, the next one we are going to end up having to solve because when you multiply both sides by negative 2, this ends up being a positive 12 over here. So we're going to get y minus 10, absolute value of y minus 10 equals 12. So we will have to solve this one, or I guess keep solving this one. So let's see, y minus 10 equals 12, y minus 10 equals negative 12, 22, and negative 2. We got to make sure they both work. So 22 minus 10 would be 12. Absolute value of 12 is 12. 12 divided by negative 2 is negative 6. Good there. Negative 2 minus 10 is negative 12. Absolute value of that is 12. 12 divided by negative 2 is negative 6. All right. So they both work. Great. Questions on the front side? All right, let's keep going. Flip it over. Okay, I'd say add 11 to both sides. So that would be 6 equals the absolute value of 8 minus p. And when I write both equations, I'm just going to flip around the entire thing. So we'll have 8 minus p equals 6, and then we'll have 8 minus p equals negative 6. If we subtract 8 from both sides, that would be negative or opposite p equals negative 2. And now we have to either multiply or divide both sides by negative 1. Just take the opposite of both, and you get p equals 2. Over here, same idea, subtract 8 from both sides. That'd be the opposite of p equals negative 14. Take the opposite of both of those, p equals 14. Now we got to double check, make sure they work with the original equation up here. So let's see, 8 minus 2 is 6. Absolute value of 6 is 6. 6 minus 11 is negative 5. So that's good. 8 minus 14 is 6. The absolute value of 6 is, or I guess it's negative 6. Absolute value of negative 6 is 6. 6 minus 11, negative 5. So once again, these are both just fine. They both work. We're good there. All right, 10. This is the first time we've seen something equal to 0. 0 is actually kind of convenient. Yes, there are solutions. There probably will be 2. We're going to start by multiplying both sides by 9, which conveniently enough doesn't change anything on the right. So the absolute value of 3a plus 12 equals 0. And because 0 is its own opposite, we don't have to write 2 equations here. We just need to write 1. So that would be 3a plus 12 equals 0. There's only going to be one answer for that one because 0 is in the middle. So absolute value of 0 is 0. Only one solution possibility for that. So makes it kind of nice. So if we subtract 12, that would be 3a equals negative 12. Divide by 3, and a equals negative 4. And if we take that back up to the original equation, 3 times negative 4 is negative 12. Negative 12 plus 12 is 0. The absolute value of 0 is 0. And 0 divided by 9 is 0. So, good to go. All right, any questions on that one? Number 9, okay. Are you good with adding 11 to get positive 6 here? That's the first thing we do. Okay. Everything else make sense? Okay. All right, number 11. Let's go ahead and get rid of the 9 first. So we'll subtract 9 from both sides. So what would negative 15 minus 9 be? Negative 24, all right. So that'll be negative 4 times the absolute value of c plus 10 equals negative 24. And we still have to do one more thing to isolate the absolute value, which is to do what? Was it? Let's do the opposite. Divide, yeah. Let's divide by negative 4. So we'll get c plus 10, absolute value of c plus 10 is positive 6, because the negative divided by a negative is positive. So, maybe somewhat unfortunately, we have to keep working on this one. So you write your 2 equations, one of them equals 6, the other equals negative 6, and then we'll go back and double check. So we're going to have c plus 10 equals 6, and we'll have c plus 10 equals negative 6. So that would be negative 4 and negative 16, what it looks like. And then double checking these. Let's see, negative 4 and 10 is 6. 6 times negative 4 is negative 24. Negative 24 plus 9 is negative 15. So looks good for negative 1. Negative 16. Negative 16 plus 10 is negative 6. Absolute value of that would be 6 times negative 1. Negative 24 plus 9 is negative 15. So those both check out as well. So we haven't had any extraneous solutions yet. Everything that we've got an answer for so far works with the original equation. Oh, here's the next one with a bit of a fraction with our variable. Let's see what happens on this one. How about subtracting 8 first? I actually think that gets us the same number as we had initially over here, because negative 16 minus 8 would be negative 24. So let's see, negative 24 equals negative 12 times the absolute value of k divided by 5. And then we'll divide again. This time we're going to divide both sides by negative 12. And that'll be positive 2 over here. So that'll be 2 equals the absolute value of k divided by 5. We'll get a couple of different equations. We're going to say k divided by 5 equals 2. And we'll also have k divided by 5 equals negative 2. All right. Do those both work? Let's see some nodding. Yeah. Yeah, we plug in 2. Let's see. Positive 2 would be 2/5. Right here. Absolute value of 2/5 is 2/5. 2/5 times negative 12. Oh, wait, we're not done yet. We got to solve. Sorry. How about 10 and negative 10 for k? Multiply by 5. K equals 10. Sorry, I need to finish this problem first. K equals negative 10. Let's try that. 10 divided by 5 is 2. 2 times negative 12 is negative 24. Plus 8 is negative 16. Oppositely, it also works with negative 10. So yeah, these both work. All right. So nothing with extraneous yet. However, take a look at 13 real quick. What's different about 13? That's another variable. Yeah, it's not just equal to a number now, it's equal to a number plus 1. So is our absolute value isolated? Like, is it by itself on one side of the equation? Yeah, okay. So this is going to look a little different because before we said it's equal to the positive and negative version of the number over here. But now it's not just a number, it's an expression. So our two versions will be 3x minus 9 equals x plus 1. And if we're talking about the negative version of x plus 1, that would basically be x plus 1 as a group with a negative applied to both things on the inside. So what that ends up being would be 3x minus 9 equals the opposite of x minus 1. Both things become their opposite values. So if there's more than one term as an expression on the opposite side, once you've isolated your absolute value, take the opposite of everything over here. All right, so now in terms of solving, we got a little bit more to do. So we're going to subtract x from both sides. That would be 2x. And if we add 9 to both sides, that would be 10. So we can just say 2x equals 10. And we'll divide by 2, and x equals 5. So I did two things to get from here to here. Subtracted the x and added the 9. Now over here, we're going to add x to both sides, which means we would have 4x over here. And if we add 9 to both sides, that would be positive 8. Negative 1 plus 9 would be 8. And if we divide by 4, that would give us x equals 2. Do both of those work with that? Anybody check those yet? I think they do actually on this particular one. But by the way, extraneous usually ends up happening where you have another variable, but I do think both of these work. So let's try it out. 5 times 3 is 15. 15 minus 9 is 6, right? And then over here, 5 plus 1 is 6. So 6 equals 6. Looks good. 3 times 2 is 6. 6 minus 9 is negative 3. The absolute value of negative 3 is 3. And then over here, 2 plus 1 is 3. So 3 equals 3. All right. So those are both good. Any questions on 13 before we look at 14? Has anybody tried 14 already? Anybody moving ahead? See what happens on this one? All right, let's see. What do we have to do first on 14 before we can write our two equations? Divide. Good. So divide by 2. So you got absolute value of h plus 8 is equal to 7h. Now we're going to say h plus 8 equals 7h, and then h plus 8 equals negative 7h. All right, because we have a number and a variable over here, I'm just going to move all my variables to the right side this time. So if I subtract h from both sides, that'll give me 8 equals 7 minus 1 is 6, so that's 6h. Divide by 6, that would be 8 over 6, but those both reduce by a factor of 2, so that would be 4/3. So 4 over 3 equals h. That's one of them. This one over here will be a little bit simpler because when you subtract h from both sides, that would be 8 equals negative 8h. Dividing on that a lot easier, just equals negative 1. So h on this one is equal to negative 1. Let's start with the easier number first. See if that works. So negative 1. If we plug in negative 1 for h, negative 1 plus 8 is 7. The absolute value of 7 is 7. And 7 times 2 is 14, right? So the left side would be 14. What does the right side equal? Does it equal 14? What does it equal? Negative 14. Yeah. So the left side ends up being 14. The right side ends up being negative 14. So this one does not work. That is extraneous. That is what an extraneous solution is. Looks like it's an answer. It's not an answer. By the way, if they're both extraneous, which I don't think you'll see, but if they both are, then that would probably mean no solution. But I don't think we'll see that. All right, next one here. We got 4/3 plus 8. I think it's 28/3. Yeah, times 2 would be 56/3. So what does 14 times 4/3 equal? What's 14 times 4/3? If it's 56/3, we're good. Yeah, I see some thumbs up. Cool. So we have one answer, and the answer is 4/3 because both sides of the equation end up equaling 56/3. All right. Two more. Here we go. These last two, a little bit funky. Tell you what, I want you to do both those last two do on your own. So 15 and 16, try those on your own. And I'm gonna go ahead and freeze my screen over here. And then we can check back in and let's say, I don't know, 3 minutes, 4 minutes, somewhere in between there. And if you want to, check in with a neighbor or something like that while you're working, that's fine. And then we'll get the assignment handed out and hopefully we'll have a good amount of time to work. Yeah. All right. That'll work. There it is. All right. So with number 15, I got 3/4 and I got -5 halves. However, only 3/4 works. -5/2 did not. Questions on that one? Good, all right. And then on 16, they both worked. -11/5 and -9. Okay, so 15, yeah. So let's see, so I started by adding 5n to both sides to get rid of the -5n here. And so that gave us the absolute value 8 minus 2n equals 6n plus 2. And then stuff inside the parentheses is equal to 6n plus 2. And then the other equation, stuff inside the parentheses equals -6n minus 2. Take the opposite of both. The problem. No. So everything in here is either equal to this or the negative version of this. That would be 6n plus 2 for this one, and the opposite of 6n would be -6n, the opposite of doing it. What's that? You saw it? Okay, cool. All right. So let's go ahead and get the assignment handed out, and then you'll have until the end of class, which I still don't remember the schedule. So what is it? 39? Is that right? 10:39, second period? What's that? 32. 31. Okay. 30 something. All right. All right. So go ahead and start working on this. I will figure out exactly what minute we're at here. 31. Okay, 31. All right. So that means you got about 16 or 17 minutes left, probably 17 to that clock. 6. So decent amount of time to work. Depending on your speed and accuracy and efficiency, maybe you'll get most of it or all of it done.